Okay, so today the plan, we should really finish about the complete postconditions, and then we have to move on to the math models, which will be relevant to your lab number 2. We'll get there. For the last bits, well, actually quite an important part for the complete postcondition, don't miss the big picture because we've got 5 versions for you to consider. You should really know what's the purpose for each version, okay? Let me just give you, again, a very big picture, okay? Whenever you're trying to do your development, you know, maybe just maybe a collection of classes, and also for each class, you got a collection of features. For each feature, this is what you have to think about. Let's say I got some feature F, take some input parameters, and then we got precondition over here. Okay, something here. And then we got implementation. And then we got postcondition, right? And there could be something here, and then end. Okay, that's the general layout for any feature that you want to program. Can be command or can be query. Now, this is something you want to realize. This part here is the implementation, which would be the supplier's duty. Okay, this is the implementation. On the other hand, this part here is the postcondition. Right, we know this very well. What I would like to point out again to really see what's really the purpose doing 5 versions. You want to think about the pink and also the green over here are more like independent entities. They are basically done independently. What do I mean? When you are trying to design your postconditions over here, what you really want to aim for is to put as much constraints on the supplier as necessary. Of course, not too strong, but it's got to be reasonable. So you want to be as complete as possible for the postcondition. On the other hand, for the implementation over here, you cannot assume you will always do the right thing. It may not. Okay? So this may be correct if you're lucky, or it may be incorrect. So now, in the case of incorrect, which might occur more often, you want to make sure your complete postcondition can catch this. Remember what we said before, what does it really mean to be a good contract? So that means when something that goes wrong, the contract wouldn't just stay silent. They're going to tell you something that's wrong at the runtime. Okay? So now we're going to see if we try to adjust the pink part to be incorrect for different versions. Right? We're going to say, just talk about a particular wrong implementation. We want to see how exactly can we make this particular part of the postcondition as complete as possible. So that's kind of the idea. But of course, eventually, once we get to version 5, that will be complete. But before that, we're going to see why other 4 versions are not really complete. Okay? That's a big picture you want to keep in mind. Let me just review very quickly what we did last time. Okay? We talked about 2 classes. We got the class called account, where we got owner and balance. Right? We got, for example, Steve and Bill with different balance. And the most important feature you should know about in the bank class, right? There's another class called bank. Is the account of. So this is the feature we're going to use heavily in order to write postcondition for this particular case study. And this particular one is saying, given some owner name, we're assuming that in the precondition, the owner actually exists in the bank. What we return is simply just an object of the account. Is somehow similar to what you did in lab number 1 called get vertex, right? Given the item value, you want to return the vertex objects that has the same item value. It's similar. Okay, I thought you might just draw that analogy. Okay, that's the account of. Okay, make sure you can remember what this account of is going to do. Okay, that's something we're going to see today. Okay, what we saw last time was the version 1 and version 2. Let's just see very quickly what was the story. And for each of the 5 versions, we want to make sure the following. Okay? We basically created a very simple bank. We simply got 2 accounts over here. We got Bill and we got Steve, only 2 accounts. And then the command we're calling is called deposit on. For example, we want to deposit only onto the Steve's account from 0 to 100. That means Bill, his account should remain to be 0. And Bill should be changed to 100. Okay, it's a very easy case. Hopefully, supplier will be correct. On the other hand, our contract will be complete. That's the ideal case. So we got some balance over there. But it's not quite the case. You definitely cannot rely on your lock. Let's see. Version number 1, very quick. Version number 1 basically is telling you the implementation we're considering just happened to be correct. just happen to be. So you don't really see the value of having complete postcondition. But just to notice that when we see the ensure clause over here, okay, if you see that over here, we simply check to see the number of accounts should stay the same. And also we want to make sure the balance of the particular owner we want to change. For example, in this case, we want to change for Steve. So that means over here, N is simply just Steve. We want to make sure Steve's account is incremented, right? We talked about it last time, okay? But that's the only postcondition we have about account changes. Did we say anything about Bill, for example, the rest of the bank? It seems like we have not. So that could be an issue. For version number 1, having incomplete contract doesn't seem to be an issue, simply because you're lucky, because supplier did the right thing. But that's not the general assumption you can make. Let's look at version number 2. For version number 2, we are mainly trying to injecting an error into the postcondition. Okay, let's have a look. So whatever that happens before will just be the same as before. Okay, so this part over here is a correct implementation. Just assume it's there. When you download the source code, you will see they're there. And now in version number 2, we're simply introducing this particular error to say not only that you're going to deposit onto Steve, but also I'm going to change Bill as well. But now so that's apparently there's something wrong. But is the contract, the postcondition specifically, going to tell us something at the runtime? Not really, but let's see why, again, very quickly. And then we can move on to the other 3 versions, which would be quite important to understand as well. Let's see over here. Let's just have a look at this particular postcondition again. If you look at this one here, you can see we're apparently using the old keyword over here. The best way for you to understand is to see which expression value is going to be cached or to be stored in the PreStates. In this particular case, after the old keyword, you can see the longest unbreakable expression is basically this expression over here, which means go to the current bank and then call this account off on N over here. What's N? In this case, it's simply just Steve. Okay, just remember that. Okay, so I will go back here. So Steve will be here for N, and then we simply go to the balance. So after all, we're going to cache just an integer value. Are we okay with this? This is based on our understanding from last Wednesday, when we talk about the variety of cache expressions. Any question for now? Okay? Okay. Let's just see very quickly why this would not be enough. If you think about it, this particular green one is going to be cached. So think about in the PreStates, right before we try to call the implementation of this wrong version, right before we call that. So we're going to say some cache value, let me just old expression, old value, okay? It's assigned to whatever this green box is. So now in this case, it's going to be N, which is Steve. What's the PreState value for Steve? In this case, well, just 0 over here, okay? So now remember that it's just going to be 0. And then after that, we're simply just going to execute this particular implementation. Apparently, for the first part, as in version 1, it's going to deposit 100, oh, don't forget it's 100 in this case. It's going to deposit 100 into Steve's account. That part is okay. Okay? At the same time, this particular wrong line of implementation is also going to change the very first account in the bank. Also deposit 100 into it. That means we're also going to deposit 100 into Bill's account. Apparently, this is wrong. Okay? Something has gone wrong in the implementation. Is the contract going to tell us about it at runtime? The answer is no. Simply because if you try to evaluate this particular postcondition over here, it only has the concern about the balance for Steve, right? In that case, the PreState value is simply just 0. What about the PostState value? In this case, if you try to, let me clear that a little bit for you. So you can see, apart from that, there is another value over here that's in the PostStates, right? What's the balance of Steve's after the change? It will simply be 100. It's easy to look up. So that means you got 100 equals, and then this particular expression value has been cached from the PreState, which is 0. Will be 0 plus whatever amount. In this case, it will just be 100, right? 100. You can easily evaluate, it's simply just true. So that means the post condition is actually fine as far as Steve is concerned. And that's it. No post condition on the rest of the bank. That's the problem. Are we okay with why version 2 is actually problematic? You might think to yourself, well, there's actually no contract violation at the runtime, so I should be okay. No, because apparently the implementation is wrong. It can be wrong in different way, but it's a particular way it's wrong. So the counter shouldn't stay silent. What we want to do now is to move on to the other 3 versions to see how we can look after the rest of the bank. Okay? I started you with the pattern last time. Let me review very quickly, and then we can see the solution. Okay? Think about in this way. If this is our bank accounts, imagine that, let's say here. Let's say this is the accounts array. Maybe somehow we are trying to deposit onto Steve. And let's say Steve exists over here, for example, in general. Account, and let's say the owner and also the balance. The owner is simply Steve, and then maybe some initial balance. Okay? What we want to say now is to say 2 things. Number 1, we want to make sure Steve's account is really deposited and incremented for its balance from 0 to maybe 100, for example. But what's more important is we want to make sure the rest of the bank over here, like before Steve and after Steve, they stay the same. That's something we want to make sure. And what we talked about last time was using a universal quantification. Basically, we want to say for every account over here in the PreState somehow, every one of them, if they are not Steve, in that case, they should stay the same. Otherwise, if we are talking about Steve, it should be changed. Okay? I'm going to show you the precise wording. I just want to review quickly, because we talked about this already on Wednesday. Conceptually, are you okay with what we're going to write? Okay? Let's take a look. So we got 3 more versions to look at. Let's go to version 3 and see what happened. Okay? And you tell me whether that should be satisfactory or not. And for what reason? Let's say for version number 3, we still got our bank, but now we got deposit on version number 3. Okay? Again, this part here is simply just omitted. So that's the correct implementation by running the loop. But we're just injecting the same error. So now supplier is doing something that's wrong. What we're doing now is this is what we had from the previous 2 versions, but now we're adding something new. So what do we add? We want to specify others unchanged, kind of similar to what you would have done in lab 1. Let me just show you this contract over here. Stare at that for a moment. And let's understand what the logic is first. And I think maybe the trickiest part for this particular contract is about when, excuse me, when you call current.accountOf. Okay, why are you doing current.accountOf? Okay. Anybody can try to just explain to me what this is trying to say. This particular post condition here, others unchanged, just roughly, informally. Anything that's not the owner is changed? Say that again.
All the accounts that don't belong to account.owner are changed.
Okay, let me try to lead you a little bit. Let's not worry about what we are crossing over in just a moment. Okay, let's not worry about it. Why do I need this? Well, apparently I'm using an implication. Why do I need an antecedent over here to say ACC.owner? Apparently ACC is whatever account I'm currently looking at, right, in the context of the cross loop. Why am I saying ACC.owner not equal to N? Why am I saying that? N is the one that we want to change. And we are saying that if the current account has the owner that's not equal to the one we want to change, then you go ahead and do the consequence, right? Okay, that's a very important key. And the consequence over here is simply say, if it happens that the current account I'm looking at, for example, maybe Bill. Bill is not Steve, which means we don't really intend to change Bill. In that case, we're going to say the Bill's account should be equal to somehow the current one. Just use the bill's name to look it up. So now ACC over here, where does it come from? Apparently, it comes from somehow the old version of the accounts. So conceptually, this is what we are doing. Go over the old version of the accounts array in the pre-states. Go over one by one. Now compare this particular old value for the account. For example, let's say Bill's account. Apparently, Bill is not Steve. So that means Bill's account in the pre-state should stay the same as Bill's account in the post-states. Okay? Let's do a little bit of annotation here to get you more comfortable. And then we're gonna, well, just understand the logic first, and then we'll talk about whether that's correct or not. Jordan.
Sorry, can you just go back to the last one?
Last one? You mean the version 2? Or just the slides?
Version 3, yeah.
We are now in version 3.
So like for the like just the previous one where like the codes.
You mean over here?
No, the other way.
The other way? Sorry, you mean the slides or the iPad? Over here. Okay, maybe that's what you meant. Okay, go ahead.
When you say across old accounts, does that just copy the address of the?
Ah, good. So Jordan's question was, when we say across old accounts, what exactly are we crossing over? I would say I will get to that in just a moment. Yeah, that's a very important question.
Yeah.
Conceptually, let's say this. Conceptually, what we meant to do is to go across the old version of the accounts array, old version, so that we can compare the old version of each account one by one. That's our intention. But is this really going to achieve it? That's our question. Okay. Let me just go back to iPad here and then give you a little bit more annotation, and then we can discuss. Let's take a look over here. Okay. So of course, you might have to spend a little bit more time on the logic, but I just want to say to you, this particular antecedent over here tells you if it is the case, the accounts, let me make it thinner. If the accounts owner is not the one, which is n, to be changed. That's the antecedent for the implication. What about the consequence over here? If you look at the consequence over here, implies ACC, right? Apparently, we meant to say ACC because ACC is a dummy variable we introduced. When we talk about old accounts, it's meant to be the old version of the account. And then when we say current, apparently it's actually current in the post states, right? Whenever you talk about current, it's basically in the post condition already. So this is the post states. In the post states, we are simply calling account of ACC.owner, right? We're comparing the new version against the old version. So the whole thing over here, if you think about it, so this is the new version of the account. Okay, any question about the implication over here? I just want to point to you, and then we're going to run it as well. Okay. So now, go back to Jordan's question. Given that we understand conceptually, but when you actually want to execute in the program, you want to be precise. Is this particular version going to work? Is it going to work? We'll make it more precisely, Jordan. Do you think this predicate here, like a Boolean value, would it always give you true or false? Always give you true. Okay, that's something to know, but we're going to see why. So, exactly, because it's basically invisible, right, for the changes. Okay, let's see why. Basically, keep in mind, this particular expression over here is always going to give you true, always. So if the post condition is satisfied, it's not going to give you the alarm at the runtime for this wrong behavior. Okay, let's see why. The only O expression we have is this guy here, right? That's the only O expression. Now, what exactly are we going to cache? The reference to account. That's very precisely. Thank you. So let's see this. So let's say for now. So in the pre-states, I'll do it here. Right before we try to execute the body of the implementation here, we're going to get, let's say, old accounts. It's just assigned to exactly this expression here. And that will simply make it point to this accounts array over here. Everybody agree? That's in the pre-states. Now, you might be able to already, right, to predict what's going to happen. Let's just do it. I think that's important. It's getting a little bit messy, but I'll try to stay clear. When we say across all version of the account in the post condition, that means old version of the account is basically a reference to this particular array. We're going to go over it. And we're going to run 2 iterations, agree? 2 iterations, right, for this particular array. So now, for the first iteration, and which ACC are we talking about? Basically, we're talking about this particular array, and the first iteration is referring to this particular account. Okay? So now, for that one there, we're saying ACC.owner, which is Bill. Is Bill the same as, oh, don't forget, we are trying to say deposit Steve. So that means over here, N is actually Steve over here. Bill is not the same as Steve. Would that be true or false? True, right? Don't forget it's negation, right? Okay. Let me just put it here. Steve, not the same as, oh, sorry. Let me write it precisely. Sorry about that. So the current line we are looking at is Bill. Bill is not the same as Steve. That was simply just true. And then we say implies. And now, how do we evaluate this expression over here? When we say ACC, that is supposed to be the old version of the account. What's ACC? Well, wouldn't that just be this particular account, just ACC, right? That's what we are pointing to. That's a green one. Now, can you tell me when we call current the account of ACC, the owner, in this case, that will be Bill. Which account would it be? The same account, because now hopefully you see that here when we say current is simply this bank over here. Accounts, you follow this link, you will go to just the same array. So when you say current, the account of, you will still point to the same account objects, just the same. So you're saying one object is equal to itself, which is always true. Okay, so that would be simply current. Oh, okay. For this one here, it would just be true, okay, for what I just explained. Can you tell me what happened to the second iteration? Would it be true or false? Just for the second iteration. Tell me the result first. True for the same reason or for a different reason? Different reason. What would be the reason for the second iteration being true?
Because now the account owner does not equal N.
In that case, the antecedent would just be false, right? Very good. Let me just write it down. It's really important, right? So now for the second iteration over here, we are basically talking about, again, for the second iteration, ACC will still be the second account for all accounts. So now, if you follow the link, and then the second one will just be this particular account. The owner is Steve. So now we have Steve over here, not equal to the N that we are trying to change, and then imply something. This is already false. Agree? In that case, for implication, if the antecedent is false, you know that the whole thing would just be true, trivially. We're thinking this way. Second iteration is basically the case that we don't care, because we only care those accounts who are not Bill. Oh, sorry, who are not Steve, because we want to change Steve. When you're encountering Steve, we don't have to worry about it. Okay? So now the whole thing would just be true. And don't forget, when you have implication, false implies anything, will just be true. Overall, it will just be true for this particular postcondition, which is problematic. You got something wrong from the implementation, but it gives you true. That's not good. I would say the logical pattern over here is pretty accurate. The only thing is, when we go across the all accounts, it seems like this expression over here is what the problem is. All accounts, in this case, simply just make a reference copy over here of the array. So that means every time you're comparing the object with just itself, because it's aliasing from the original array. That's why version 3 is actually not right just yet. Everybody okay with this? Any more explanation needed? Yes? Complete contract. Oh, when I say complete contract over here, I simply meant, okay, the question was about the complete over here, right? You also see that in the slides. I meant the following. When you examine this particular post condition here, you basically got, number one, it worries about the account that's going to be changed, in this case, Steve. Right? It's simply saying, if you try to look up the balance for n, which is the one we want to change, it should be modified to from 0 to 100, number one. And then in the second one, you also meant to check the rest of the bank. So you actually try to fulfill the two intentions. But it's not quite there yet. But I would still say it's complete. It's just not perfect. It's not quite correct yet. How about that? It's complete, but not quite correct yet. Yeah. Okay, so now that's about version 3. And version 4 and version 5 will be very similar, very similar. We know that the problem really is about the objects being a crossover. So why don't we try to change it? Currently, we're simply using reference copy. Now, question for you. What options do I have? I can either do shallow copy or deep copy. Now, question for you. Can I do shallow copy and make it correct? I heard no. Sure, but do you know why? How about we look at that together, okay? But you're actually right, apparently. Otherwise, there wouldn't be version 5, right? Otherwise, we would have stopped in version 4 already. Yes, question, yeah.
I don't think shallow copy.
That's okay, yeah. Basically, the intuition will be because the change we're trying to do is beyond the first level. Yeah. That's why. Let's see exactly how this will work out. Let's do quickly. Now for version number 4, let's take a quick look. If you do version number 3, basically, if you look at T1, that means there's no post-condition violation occurring. So that's not good. That's what we're expecting to see. For version number 4, we do exactly the same setup. The same wrong implementation, and also this is the part about what should be changed. Let's see, the others unchanged. The patterns stay the same. Stay just the same. The only thing I changed was old accounts.twin. That's the only thing I changed. Okay, for those of you who may not be able to think about that fast, why don't you look at that again? Do you think what we worry about in version number 3 will still be a problem? Or you think this is fine? It's really going to have a post-condition violation as expected? You want to picture what's going to happen at the runtime in your mind and see what does it really mean when I have old accounts.twin. Is it really going to keep the change between the pre and post states? Jordan.
So it's going to copy all the pointers for the accounts, but the account balances could change. And if you so let's say you had added like 100 to each of the balances of each of the accounts, right?
Mm-hmm.
Then there would be no issue detected because it would be using the same account.
Which means we cannot detect it.
Yeah.
Yeah, let's see exactly. Yeah, what Jordan said was exactly correct, but I would say for everybody's understanding, let's go over just quickly. Okay, let's go back to the slide over here. So you can see now I changed to version number 4. Okay, the logic pattern stayed the same, so I don't need to repeat. The only thing that's different is over here, old expression, and the thing we want to catch will be accounts.twin. So now in the pre-states over here, let's say we have some hidden variable on old accounts. And now it's going to be assigned to this particular value. Now, would you agree we need a new array? Okay, that's a shallow copy. So now it is going to point to a new array of size 2. And then 0 and 1, 0 and 1. Now, do we have to create any new objects further? No, we don't have to, right? Just reference copy. You can think about old accounts at position 0 is simply assigned to b dot, what b is here, right? B dot accounts at position 0. That's basically shallow copy, right? So that means this one here is going to point to the first account. And this one here is going to, well, let me try to make it more visible to you. This one here is going to point to this account. Only a new array is created, but all the accounts are just reference copy. That's that's definition for shallow copy. Are we okay with this? Well, if you're okay with this, now we're almost done. Okay. Again, we're going to trace it quickly for the first and second iteration. Okay. Let's see that quickly. If you try it, so now after this particular wrong implementation, we're going to deposit into Steve into 100 as expected. On the other hand, we're also going to mistakenly deposit into bill 100. That's a wrong implementation. And now, when we try to evaluate this particular guy here, would it be true or false? True or false? If it's false, then we are done. That means it's a good postcondition. If it is true, that means we're not there yet. Let's see. I heard true. That's good. Let's see for the first iteration, right? For the first iteration, we say old, since we're going across all accounts twin. All accounts twin. The first account is pointing to this particular account objects over here, right? The owner is Bill. And we say Bill not equal to Steve, right? The same as before. Implies. This part here, we know it is true. So we got to evaluate further. Now for this part here, would this be true or false? Well, first of all, what's ACC? ACC is whatever account we are going across over from the old version. The old version of the array currently is looking at index 0. So the green one is ACC, okay? Let you make a note here, ACC. And what about over here? Current.account of. Where's current? Current is the bank, the context objects. Current bank accounts, and then it's pointing to this particular array. It's also talking about what account of is going to return. The account at position 0 with Bill. In that case, it's really the same account objects. So the green and the orange, they are the same objects. So are they the same objects? Of course. So you just get true here automatically. In some way, it's also trivial because you're still ending up comparing the same objects. Okay, and then similarly, for the second iteration, would it be true or false? True, for the same reason. Okay, I'm gonna leave you with that. You simply say Steve would not equal to Steve would just be false. So antecedent being false, so it would be true automatically. Okay, so you just get false implies something. Overall, just be true. So since like overall we still get true for this particular postcondition, we're not quite there yet. We're making some progress. At least we try to make some new array, but not new accounts. So what option do we have left? Deep twin. Let's take a look, okay, to finish the story. And then I'll give you some exercises to think about, and then we can move on to math models. Okay, for the last version over here, for version number 5, we still got the same wrong implementation here, and then we got now across all accounts that deep twin, right? That's what we have right now. So now let's see exactly why this is going to give us a postcondition violation as expected, because something is wrong. Let's see this. So now again, old here, the keyword, and then we are going to cache this particular value, deep twin, which means we're going to recursively duplicate the whole structure for the accounts array. Okay? So now what's going to happen is, in the pre-states before, right here, so the old accounts, first of all, like shallow copy, is going to be a new array, index 0 and 1. And now, do we have any aliasing? Do we? No, we don't. We're going to duplicate this particular account, also duplicate this particular account separately. So that means over here, you're going to have just another accounts object over here. And then we have owner, we have balance, and then we have bill, 0. That's in pre-states. And also, we have also duplicate this particular account objects, ACC, the owner and the balance. And that'll be Steve. And then 0. That's in the pre-states. We're only doing caching. Again, this is done automatically for you. Let's say we try to do the implementation here, which is going to deposit into Steve 100 as expected. On the other hand, it's also going to deposit into Bill 100. So now you can already see. Later on, when I try to compare the two versions of the account, this version over here for Bill is definitely different from this version of Bill, right? So now we will be able to see the changes. Okay, let's see one more thing, and then we are done for this example here. When I try to evaluate this particular postcondition, again, 2 iterations, just for the first one. Second one is the same reason why it is true, just because of false antecedents. For the first iteration, okay, so now ACC.owner, Now ACC is basically going across the deep twin copy, right? So ACC will simply just be, in this case, just here. Okay, this is ACC. Okay, the owner is Bill. Now, Bill not equal to Steve, which we want to deposit into. That will simply be, of course, just true. Implies, so now how do we evaluate the consequence over here, right? The left-hand side, ACC, is exactly over here. But what about here? Are we going to get the same ACC like the previous versions? A different one, right? Simply because, now, if you say current right now, current is a context object for the bank. And then when you say go to accounts, you're now referring to this particular array. So now you're searching through which account has bill. Oh, sorry, which account has bill. ACC, the owner in this case will just be Bill. In that case, you'll find that it's exactly this account over here. Now, if you compare the green and the orange, are they the same account objects? They are not, because one has 0, the other one has 100, so they are not the same. Okay? So now for the first iteration, it's simply going to give you false. Okay? Overall, it's going to be false. So it's going to be a post-condition violation. And this is as expected, because the implementation is wrong. Okay, we have now seen all the 5 versions. Of course, only the version number 5 should be adopted in your lab or the projects. But you should really know why all the previous 4 versions wouldn't work. So you always remember. Okay? Okay, any questions about this? Yes?
In lab 1, we have a add edge.
Yeah.
Can we do that?
Yes, you may. You may. For your lab number 1, okay, the idea would be something like this. If you think about the edges, edges I believe is array, right? It's an array of edge. But conceptually, think of it as a set. Let's say this is the old version of the edges. And then when you call add edge, and then you simply pass maybe, for example, edge E, like that. In that case, that means conceptually you're basically growing this particular set over here, and you're adding one element to it, basically, right? Which should be just E. That's the only one. Well, conceptually, if you think about edges over here, and this is the, okay, think about this is old edges, okay? Old, and this is new. New edges. It's a sketch. All I want to do is the old edges is a proper subset of the new edges. It should be a proper subset because it's exactly one more element that's in the new edges, right? Now, how can I write this? Remember, before we write this particular others unchanged, let's put the context here. For your add edge, let's say E, okay? Just make it simple. And then for your ensure, I don't quite remember exactly, but it should be something like this. First of all, you have something like a count incremented. You say something like edges dot count equals old edges dot count plus 1, right? That's the first one, to make sure the set difference is exactly just 1, okay? And then you got another one called whatever that's changed. That one there, I'll leave it to you. That one should be easier to specify, okay? What about others unchanged? So now we are pretty sure the size of this particular set is exactly one more than this one because of the previous contract over here. That's something we're pretty sure. So now how can we write the last one?
Does the order matter?
The order doesn't matter, I can tell you. As far, well, think this way. As far as a graph is concerned, do edges have order? Not quite. So it doesn't matter. That's okay. You know, I'm just showing you one possible solution. So now, basically, what we want to say is, let me tell you what you can think of conceptually and then write it out together. I want to say, how do I know? Well, back in 1090 or 2090, how do you prove the green is a subset of the orange? Yeah, I want to say everything in the green is also everything in the orange. And now, if you say everything, should you need a cross loop? You may be, right? Across some, across all. Across all, it makes more sense. Okay, let's write it down quickly. So now I can say, I'll give you one version here. I can say across the old version of edges. And then, let's say is E, right? I'm saying every element here is called E, for example. Just say E2. Just not to be confused with the E, okay? Just E2. And then I would say all here, and then N here. Okay, let me, okay. And then over here, I'm just going to say, how can I want to say in the new set, which is orange, right? I want to say this set actually contains E2. Yeah, I'll come to you. I might know what you want to talk about. Yeah, give me one moment. Yeah, I can say current dot has edge, for example, and then I can say E2. Is this correct? Well, given what we have just learned from the 5 versions, this kind of looks like version number 3.
Except that edges is a command, right? So
Oh, edges actually is a query. Remember,
Yeah,
it's a query, yes, correct.
So
Oh, that's correct, yeah. So now, my question for you is, do you think this is okay? Or do you think we might need a more sophisticated copy? You might need deep twin for the same reason that we said from the previous slides. Okay? So now here, rather than this, you should say old edges dot deep twin. Okay? Make sense to you? Okay. Well, that's one possible solution, of course. If you got a solution, maybe you can show it to me after, maybe during my office hour. We can take a look. Hey, any more question about this pattern here? You mean which one? You mean edges? No, edges is a query. Okay. Okay, just don't get confused, you know. Okay, you talk about edges here, right? Remember in your list graph, the way you declare edges was edges, which is an array of edge. And then you have some body of implementation for this. In this case, first of all, if edges was really a command, for example, hypothetically, if edges doesn't return anything, and then you simply got do and end. In that case, if you include edges in the post condition, it's not going to compile because it always needs some expression value in the post condition. You cannot call command in the post condition. Okay, having this set, so now edges of type array, you can think about you having its return value in the pre-states and then take a deep copy and then call it again, get a post value and compare them. You need a deep twin. Otherwise, you might get aliasing issue, which will make the changes invisible. All right, any questions? And later, once we talk about inheritance, we're going to see some interesting pattern about how you can test for violation of post condition. What's the best you could do right now? It's quite ugly. The way I would do it, if I didn't learn about this pattern, once I got my post condition, I'll simply change my implementation somehow. And then I'll run it and make sure that post condition violation really occurred. But what if I forgot to actually comment out the wrong implementation and then I submit my code? Then that's too bad, right? So now you want to have a way to really say you don't want to pollute your actual code. You have a way to separate the test out. Okay? When we talk about inheritance, we'll talk about this pattern here. Okay, so now the last bits I would like to talk about before I move on to math models. I want to show you some exercises. Now consider, okay, this let me see this. Oh, remember this account of, we still got a query, okay? Assuming that we got it. Let's consider this particular account of, how do we specify its post conditions? Okay? typically, if your query is actually returning something. Sorry, I didn't put the return value. Of course, it should be account of taking a string and then return it in account over here. I forgot to put it. How can we specify the post condition for this? Meaning that after this query, the accounts array should stay untouched. I'm going to give you some possibilities over here. This is one possibility. I'm saying the new accounts implicitly you can think about as current accounts equals old accounts. I'm saying the new one should be the same as the old one. Is this going to work? I got so many versions for you. I'm blocking out the answer. Why don't you look at all of them at one go? Remember back in your 2090, if a Boolean expression always evaluates to true, it's called tautology, right? If it's something that always evaluates to false, it will be contradiction. I can tell you some expression here is tautology. Some over here will be contradiction. What about the in-between? It's called contingency, right? Usually when you have contract, you better have some contingency because it might sometimes evaluate to true, it might sometimes evaluate to false. Okay, I want to draw some connection here. Get some idea. Okay, let's look at the first one. That one hopefully not too bad. First one. Huh? It's a tautology. Okay, why do you think that's a tautology? You're saying that always true, always. Why is that? Exactly. And let me just do the first one, okay, quickly. If this is your accounts array, let's say, and the first one here, all accounts, will simply just cache the old value over here to the same one over here. And if you simply say equals for comparing reference, would it be true? Always. So it's a tautology, so it's not very useful. It always tells you it's true. It's as if you didn't write anything. Okay, the first one. What about the second one? Seems like the second one always will give you, Jordan.
Well, what if you ran create accounts.makeEmpty?
Create accounts, you mean where?
Like in the body of the, so account does. If you ran create accounts.makeEmpty.
Create accounts that make empty. I don't think that was going to change because what Jordan was saying is like this. Let's say for the body of this particular account of, let's say, if you say creates, I tell you why it wouldn't make a difference. If you say accounts.makeEmpty.
Yeah.
Okay, that's a good question. Let's say that, okay? In the PreStates, we actually got accounts over here. Oh, Jordan, that's interesting. It's interesting. If the account is simply pointing to something here, actually not just make empty, if you assign it to any other array. Yeah, interesting.
That's the thing, like, because what I was saying before
Yeah.
was that most of the time it's not going to make a difference, but in this case it would.
Yeah.
So
So guys, it's my fault. I was misleading you a little bit. Okay, I'll take it back. Okay. What Jordan said was exactly right. Let's say this. For number one here, it's my fault, not you guys' fault, right? You just got misled by me. Okay, it's not really tautology here, because if in the body of implementation over here, if we somehow try to reassign the accounts in a way, for example, if I say, let's say accounts in the PreState is pointing to this particular array, what happens if I say create accounts that make empty? What that would do, before that, this guy here tells me I should make a new reference copy, right? So all value here is just pointing to the same over here, right? That's in the PreState, the caching. So now when I execute the body of implementation over here, that one there is going to say accounts, rather than pointing to over here, it's now going to point to an empty array, but just different reference. So now if I compare these two, they're simply just false. Okay? That's actually the only case you can catch by the reference copy in the old expression. Jordan, that's good.
But
But of course,
be doing that in the method anyway. So.
Well, again, as we said, when we write a post condition, you shouldn't assume anything.
Yes.
It might be something just crazy, right? Okay. Again, my apologies. So the first one is not really tautology, okay? Forget about tautology here, just for the first one. Okay, how about the second one? Would it be contradiction? Seems to be, because every time when you say old and then accounts twin over here, you'll always, okay, let's say this. If accounts is currently pointing to some array over here, when I cache this particular expression, I'm actually going to do accounts, and then it's simply just going to point to another array, just twin. So they are not the same. Okay, it will just be false. Okay, I'll leave the rest to you. Think about all the possibilities over here to see which one might be appropriate. If they are not appropriate, it's more important to think about why they are not appropriate. Okay, you got all the answers like either yes or no in the slides, but think about them. If you got some concern, talk to me during the office hour. Okay, I just already did the first two with you. Okay, any question about complete postcondition so far? How do you self-check if you really have got the contents? You got to think about for the different versions, what would be the consequence of using a particular combination of old keyword and also the copy, right? Reference copy versus shallow versus deep. That's something you should know. And then to judge which one is appropriate. Okay, if no questions, I'll move on to a new topic. Okay, I got about slightly half an hour. So the next topic will be very relevant to your lab number 2, which is about using math models. Okay, and I want to point out the first thing to you, okay, before we talk about the example. When you go to this particular set of slides, you will see right in the middle, there's something called math review. Well, it's about a math model, so there's certain math you want to be familiar with. And that's exactly what you learn about sets, relations, propositional logic, and predicate logic. So I simply included some slides over here just to remind you the critical concept. Especially pay attention to things like a relational override, domain subtraction, and domain restriction, things like that. You will see those terms in your lab number 2. Okay? Review them. Okay? We're not going to do exactly that in the class, but I might talk about some example. Okay, let's go to the example first. And if you go to the last slide, there's certain suggested exercises that you can do, okay, before the end of the lecture. Okay, you can try. And there will be some code available to you about birthday book. So we'll do 2 examples for this lecture. For today, we only do a simple one called stack. And then for next time, we'll do birthday book. That will be more sophisticated. Okay. Okay, let's go to the first slides and then talk about it. It's actually good to talk. Usually we talk about math models after the reading week, but this time we do a little bit different sequencing. Okay, let's see how that works. What we just talked about in a complete contract, right? Let's just do very quickly since it's still fresh in your mind. We're talking about postcondition for every attributes, especially collection type attributes. You want to make sure use the old keyword properly and use deep twin when necessary, right? You want to say that not only that the stuff I want to change is changed, but the rest of the structure is also untouched. That's kind of the complete contract we're aiming for. Okay? Okay, that's exactly what we just said in the 5 versions. But now we want to apply the same principle to a last in, first out stack. But this time, the focus would not be the old keyword and deep twin anymore. We simply give you the right version. Now we're going to see a little bit more about design. Okay? What would be a good design? Let's see the problem here. Let's consider 3 different implementation strategies for your stack. Let's say we're going to talk about 3. Let's go over them, and then we'll see how their implementation and also specification should look like. And then we'll criticize on the design. Let's say we got strategy number 1, 2, and 3. Number 1 is about using array. 2 and 3 is about using linked list, let's say. Okay, let's say for stack feature, which means as far as the stack is concerned, what feature should we support? We should support like a count, push, pop, and things like that, right? For the count, it's easy. You simply say, oh, we simply declare some implementation attribute called imp. Imp could be of type array, or could be of type linked list, okay? And then we can also support top. So now the top is something you want to memorize just for the lecture purpose. In strategy number 1, we treat the end of the array as the top of the stack. Okay? For linked list, strategy number 2, we treat the first item in the list as the top of the stack. And for strategy number 3, we treat the last elements in the list as the top of the stack. So the reason we're doing this is just to show you, for you as a supplier, for your implementation, you got complete freedom. You might be choosing 1, 2, or 3, doesn't matter. Okay? Just got to be consistent. And so we got 3 possible implementations. Let's do it very quickly. How about push? For strategy number 1, how do I push? Should I push to the front or should I push to the end? Well, if the end of the array is actually the stack, that means you should insert to the end, right? Think about it, right? This one should be quite easy. It's not hard. Okay, just force to the end. What about linked list? If the first item should be the top, so now where should I put it? The head of this list, right? Okay, there's something called put front. That's just for your information. There's a put front in the linked list. And strategy number 3 will be somehow similar to strategy number 1, but the only difference is we're using a linked list. So we'll say extend. Okay? Any confusion so far? We just got 3 different implementations. Okay? And then if you do pop, you'll be very similar. So now if you do pop, you're just going to remove the tail in the array. And then for linked list, move the cursor to the front. And then for strategy number 3, move the cursor to the end of the list. And then for both cases, you simply remove them. Okay, just about cursor operation. Okay, we got count, we got top, we got push, we got pop. Okay, so now here's my question to you. Given that we got the same type, like a stack we want to implement, we got 3 different strategies, right? Imagine that you're going to write a complete post condition for each one of them. Are they going to have the same contracts? Specifically, post condition. I heard no. Anybody would say yes? It's actually a very important question to think about, right? Because the supplier actually should get absolute freedom. There's something called information hiding. I will formally talk about it next time, but we just want to do a little bit example just for today. Okay? Let me give you a little bit diagram to think about. There's some concept design principle which is called information hiding. Okay, information hiding here. Okay, and then the idea is like this. Think about this is the supplier system, the system, the supplier, right? Supplier provides the interpretation for you. In general, you can divide them into 2 parts. Okay, the first part is public, basically. That should be accessible to anybody who wants to use this particular supplier service. So this is public. On the other hand, over here, this part here will be just private. Okay, let me make it a little bit better drawing here. You can think about this part simply just private, which means nobody should really get access to it. Okay. So now, over here, in the case of stack, we got push, we got pop, and we got count. And also we got top. So these are all the public surface that we provide to any potential clients, right? Any potential clients, they can simply make use of this particular part. Okay? So now think about where we should put imp in this case, right? Of course, the imp implementation can be, for example, array. Right? Array of something. So now, let me ask you this. If I put imp in, let me make it smaller. If I simply put it here, would it be an appropriate design choice for me? I heard no, but why would you think there's no? Anybody? It's an important thing to think about. Yes? Oh, that's one thing for sure. Okay, several drawbacks for this. Okay, let me just talk about this principle here. Okay, let me put the top maybe over here. So now again, my question was, if I put this particular implementation array in the public part, here's a drawback. Number one, the clients actually gets access to the implementation, the whole array. Typically, the client of a stack, they should only do pop and push. They shouldn't really get the access to the entire stack contents. That's definitely one drawback, I agree. Anything else? I'll give you a little bit hints. That's something you want to think about as well. A good design should be very, very strong to changes on itself, which means whenever I modify my design a little bit, everybody who depends on my old design, they should be affected to the minimum. That's some direction you want to think about. What could be the possible change in my design over here? Well, apparently the push, top, push, pop, and count, they are very standard, right? So let's say this. If I decide to really modify this array over here to say rather than an array, now I want to change my implementation strategy. I want to make it a linked list. Well, if I make it that way, what's going to happen really? For example, I'm going to go to the entire contract in just a moment, but let's just see one example. Let's talk about push, okay? Push. For the push command, of course, you're going to take some G to be pushed over. And then for the ensure, okay? If you recall over here in the table, okay, I'll just show you exactly what I really meant. You can see depending on which strategy I've chosen, let's say in the original design, I simply chose an array. So that means I'm going to say implementation of force, right? And then in the implementation over here, it will just be imp.force, and then something over here. What about the post condition? How do I specify, you know what, let me make it even easier for you, okay? So let me just go back to a slightly easier example without showing too much. Let me just use top. Top is going to return just some generic parameter. We'll talk about this a little bit later. And then do something here, and then ensure. Let's say for the first version, in the original version, let me do this again, just make sure it's clear. Array, and then of something. That's my first version. In this strategy number one, how do I specify the top? In that case, remember we said the top should be the last item in the stack, right? The last item in the array. In that case, I would say the result over here should be the same as the implementation, the last item, like that. That's the first version. Now, there's a change to the design. Let's say I decided to use a different data structure. Now it's going to be linked list. And specifically, I want to adopt this particular strategy to say, now strategy number two, I want to make sure all the first element in the list is the top. So now, is this going to affect the clients? Is it? It is, because remember the ensure part over here, this is part of the specification of top, which is accessible by clients, right? In that case, if I simply make this simply just public, that means they can simply see this. So now, when I actually modify this, I'm going to modify this into imp at position maybe 1 over here to be strategy number 1. Sorry, strategy number 2. Because you can see over here, it simply tells you should really go to the first one for the top, right? So now that means this one is actually changed, which is not good. Your interface should really stay as stable as possible whenever you do some changes to your private implementation. Okay, it's a very quick sketch. We'll definitely review this a little bit later, even more, when we talk about the iterator pattern. Okay, so this is a change on the interface. And this is not good. You want to remain as stable as possible. Any question about this? Okay, good. So now there's another issue that we want to talk about. Let's say we do make the imp to be private. Let's say we do that. But there'll be more issues to think about. Let me just go through some code with you, and then we talk about it. Let's say we have the first version. Okay, so now you can see I'm exporting the imp array to none, which means private. And the clients cannot really get access to it. Okay, so now we got imp here, imp array. And then we have when we say make a new stack, which should be empty, then we'll simply make empty array. And then that should be just imp.count will be 0. Okay, and for push. Okay, so now for push, let's not worry about information hiding just yet, right? I'll just mention that principle first of all. We're going to review that as well later. Let's just think about how we can write complete contracts. And then at the end, we're going to point out another important flaw for this particular design. Let's say for strategy number 1, the end of the array should be the top. Okay, so in this case, implementation should be easy. Should be imp.force, just force to the end. So now, how do we write a complete contract over here? I can give you the answer for this one here. Imp count should be G. That's fine. How do we specify as an exercise to do it quickly, given that you have seen the previous lecture just a few minutes ago? How do we specify unchanged?
Why is it imp.count?
You mean here? Why not imp.count?
No, why is my imp.count plus 1? Oh, because of it.
Yeah, the count over here, remember the count is the PostState value, right? It's exactly the end. Yeah. Okay, anybody want to volunteer for this? How do we specify this? Should I give you a little bit of hints? Let's say this. Let's say imp is simply an array of stuff over here, right? Okay, let's say we got 1, 2, 3, 4, 5, right? After we say push some stuff over here. It should look like something like this. Let's say this is the old imp, and there's a new version of the imp, let's say. 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then 6. Okay, that's the old version between the difference between the old version and the new version. So now, how do you write complete contract for that? Which part should be unchanged? The first 5? Yeah, I agree. So now that means this part here should somehow be identical to this part here, right? Only this is a new addition. But how do we specify that? Anybody? How do we specify that? Sure. You want to suggest to me? I'm going to write over here. Should I say across? Okay, so across imp. Yes, I will just do exactly what you say. Deep twin is something, right? Suggest a name. No problem. And then, oh, okay. Now, what should I put? It seems to me, but correct me if I'm wrong, it seems to me you're running into some bottleneck here. You're saying that, first of all, you're going across imp. Did you meant to say old over here?
Yeah.
You meant, okay, no problem. Let me just add O here. Let's say it's there. somehow you're trying to say, go across this particular old version. Okay? However, how do I know the current one I'm looking at? For example, if I'm currently looking at this particular one, let's say A is actually here in index 3, for example. What should it be equal to? It should be equal to the new one at index 3 over here. But how do you know the index? You see what I mean? You mean, oh. Exactly, I'm just trying to show you. So guys, it's a very important thing to realize why this is limited. Because in this case, if you simply go across the old m.deep twin over here, this is not going to work simply because you kind of you're losing the position of the element you're comparing. Good question here. If I say, for example, let's say current dot has. Is this good enough? You're basically saying every, it's more like a subset that we did previously. You want to say every element over here exists somewhere in the new version. Do you think it's going to work? I'll give you one counter example. How about that? I claim that it's not going to work because the following. Let's say this is, let me be consistent. Let's say this is my imp. Let's say this is my stack. Alan, Mark, and Tom. Let's say what I want to do is to say push. Let's say Jim. Okay? And let's say this. What if the supplier somehow modify the stack in this particular way? Let's say Jim is here as intended. However, I swap around the order for Alan, Mark, and Tom. Alan, Mark, and Tom. So now, your particular post condition over here, let me just copy that, right? Because that's important to realize why this is not good enough. So now, if I put your post condition over here, is it going to be true or false? It's going to be true, exactly. Because, for example, you can see over here, the first one, Alan, does it exist? It does, but in the wrong position. But somehow your post condition doesn't care, right? So that's not good enough. Okay, that's one thing. Okay, so this post condition here, not good enough. So a possible written question could be, we gave you this context over here, and then gave you this particular post condition. You want to explain whether this post condition is appropriate or not. Apparently it's not, for the reason I just explained. That's kind of the exercise that you want to get used to. All right, so now we got enough discussion here. Why don't we look at what you should write quickly? Okay, try to convince yourself. Okay, I'll look at that. Okay. We'll go across basically from 1 until count minus 1. Count is basically the current size of the stack after the push. So that's why we say count minus 1. And then we say every element in the current implementation should be the same as get the old version over here and then i.item, right? So now you can see the old m.d twin. Let me ask you this, and just to confirm with what we said before. And I'm just going to write it here, okay? Let me just try to do this quickly, okay? Give me one moment. I want to just get this version here. I'm going to change it slightly, and then I'm going to ask you whether that's appropriate or not, okay? Okay, let me just paste it. There we go. This is what you will see in the slides, right? And there's a minor detail you should really pay attention to. You can see the brackets over here, parentheses. Here's my question, okay? Let's say I modify this, okay, tell that stay the same. If I simply say old imp dot deep twin, and then I say I dot item. think about what you see in the slide is version 1. This is version 2. Do you think version 2 is going to work? When you say no, be more precise. Do you mean there's going to be compilation error? Compilation error, not runtime. Why would there be compilation error? Very good. So guys, remember we actually talked about this last Wednesday. So here's just another occasion. So why do you need brackets over here? You got to be very, very careful. You might need something like this, maybe in a lab test. You want to make sure your code compile. Again, for this particular case, this would be the expression to be cached, right? So this is to be cached at a PreState. In that case, does I exist in the PreState? Not really, so it's not going to compile. Okay, so don't even try this. Right? In case you got something like this, make sure you fix it by having parentheses. Okay. All right. Yes. Which count you're talking about? Oh, you mean the count here? Okay, one thing to disambiguate, okay, you're basically talking about the count over here, right? Okay, good. The count over here, first of all, remember we're calling this contract in the context of stack class, right? This is the count for stack. It's not a count for the imp, even though the way you implement the count in the stack is by saying do and then end, maybe by saying result is assigned to maybe imp dot count. That's one way to implement it. And more importantly, remember invariance that we talked about previously, right? How would you specify such relationship between the two counts as invariance? You might just say imp dot count equals count. You're saying the count for the stack is consistent with the count for the implementation. And the implementation might be changed from array to list or etc. Okay? A few minutes, let me just talk more. Okay? How about we do one more exercise together? Okay? I think that might be nice for you to do anyway. For the pop, you'll be very similar. Okay? For that one, I'll leave that to you. What's going to be interesting is for version 2. Let's talk about strategy number 2. Let's say we're going to use a linked list. So now you can see there's a linked list. And we would say the first item in the list should be the top. Okay? And then I want to know how am I supposed to write? Well, now for the changed post condition, I'll say imp.first should be G. That one's easy. What about unchanged? What should it be? Question number 1. Should it be the same as what we did in the strategy number 1, where the top of the stack is the end of the array? But now for strategy number 2, the top of the stack should be the front of the list. Here's my question. Right? Would it be the same or different? Well, the same. Well, when you say the same but slightly different, well, you mean they're different, right?
Still do the crossing the same way.
Okay.
But then you can change 1 to 2. Count minus 1 to 2.
Okay. Let's do this final one before we end today. Okay. Okay. Let's say we do the following. Let's say we talk about strategy number 2. Okay. We basically got a linked list. Let's say the front of the list should be, let's say this is a stack we talk about. Let's say we got Alan, we got Mark, and then we got Tom. And the front of the list should be the top, let's say. Okay, let's say we got a linked list over here, like that. Okay. So the first one should be Tom, and then this should be Mark, this should be Alan. Let's say. Okay, indices should be, let's say 1, 2, and 3. So now, if I say push, let's say push Jim, for example. So now, apparently I should insert to the front of the list, right? So now let me do that. So that means I got this guy over here is going to be Jim. And I hope I can just copy this. Yes, I can. And the only thing I got to modify is the indices. And now I want you to, now this is something you should really think about when you're trying to figure out the contracts. So now we got 1, 2, 3, and 4. Okay, how do we specify the others unchanged part of the postcondition? Apparently, the only thing that we care that should be changed is only the front. What about the rest? We're basically saying this part of the list should be identical to this part of the new list. But are they actually consistent with the indices? Not quite, right? Because it's not really like a 1 is equal to 1. It's not like that. It's like 1 is equal to 2, 2 is equal to 3, and 3 is equal to 4. Agree? So now, how are we supposed to write it?
Well, you can do implies. Well, let's say you're checking.
I can say you don't even need implies. Why don't we?
Say like PostAmbient equal to the new one.
Okay.
Into C++.
Okay. So guys, I'll leave this part here for you to write it out. We'll resume just right from here, from Wednesday. Okay? Try it.